Imagine looking at a highly advanced, a truly production-grade AI system right now in 2026. Something that can just debug a massive enterprise code base entirely on its own.
Right, something doing real heavy lifting.
Exactly. And as someone who wants to stay ahead of the curve, you might assume the secret sauce there is just a revolutionary new neural network, right? Like a smarter brain.
Yeah, that's what we've all been trained to think.
Right. But how does a chatbot actually do things? That's our mission for today's deep dive. We're decoding the defining technological shift of 2026, which a lot of people are calling the year of the agents.
It really is.
And our source material for this is a technical overview from OscarAI titled From Concept to the Power of Autonomous Agents. And what it breaks down is that the secret isn't actually a smarter AI at all. It's a vital piece of software infrastructure called an agent harness.
Yeah, the harness is everything right now. Because, an AI model by itself is, well, it's really just a text generator. It predicts the next word.
Right. It
Yeah.
just talks.
Exactly. It just talks. The harness is what actually transforms that text generator into a reliable, autonomous system that can execute real-world tasks. It's a massive paradigm shift.
Okay, let's unpack this, because the listener needs to understand this shift from just a raw model to a true agent. The 2026 industry consensus is basically defining an agent harness as this deterministic software layer that wraps completely around the AI model.
Yeah, the core formula they use in the overview is literally agent equals model plus harness.
Right, so the model, like GPT or Claude or Llama, that's just the brain. It offers the creative reasoning. But it needs, well, I always think of it like a brilliant but incredibly forgetful intern,
Oh, that's a great way to put it.
Like, they're brilliant, but they just stand there and talk at you. The harness is like the strict manager who says, here's a desk, here's a phone, here's a budget, and here's a strict checklist. So the intern actually gets work done.
Yeah, exactly. The text actually uses a thoroughbred horse analogy, which I love.
Mm-hmm.
The LLM is this incredibly powerful, super fast racehorse. But without reins, without a rider, and, a track with actual rules, it might just stand perfectly still. Or worse, just run full speed in the completely wrong direction.
So true. The harness is the body, the senses, the notebook, and the task list all rolled into one.
Right. And what's fascinating here is when you look at how this changes the system, you get some crazy data. Like analysts recently tore down systems like Claude Code.
Oh, yeah, I saw this.
Yeah, and they found that roughly 98% of the effective architecture making that system work is actually the harness. It's the deterministic software.
Wait, really? 98%?
98%. Only 2% is the base model itself, the actual AI.
Okay, I mean, that's insane.
Yeah.
If 98% of the system is the harness, have we all just been obsessing over the completely wrong thing this whole time? Like constantly chasing the biggest, newest AI models?
Honestly, yes. We spent so much time obsessing over the size of the model's parameter, like the engine of the car, that we basically ignored the chassis, the steering wheel, and the transmission.
Wow. Okay, so since we need to understand what this harness is actually built out of to, keep the horse on the track, the overview highlights these 7 structural pillars, emerging taxonomies we're seeing in tools like LangChain and Databricks.
Yeah, these are the core components that make the magic happen.
Right. So let's run through them. Pillar 1 is the agent loop, the absolute heart of the harness.
Yeah, often based on the REACT framework, reason and act. So the harness receives a goal, prompts the model to generate a plan, and then, and this is crucial, it halts the model.
It stops it from just rambling on.
Exactly. It forces a plan, act, observe, repeat cycle, which leads right into the second pillar, tools.
And tools aren't just like giving the AI a web browser, right? This is controlled access to APIs, web search, databases, even code execution. The harness actually validates what the model wants to do and runs the API call itself.
Right. The harness does the heavy lifting. And then it feeds that raw data back to the model, which is why you desperately need the third pillar, memory.
Because without it, the model just gets amnesia.
Pretty much. I mean, it's managing short and long-term state. If a task takes 40 steps, you can't just shove all 40 steps into the prompt. You'd hit the context limit instantly.
You'd get massive context drift. The model would literally forget what the original goal even was.
Yeah, exactly. So the harness uses vector databases to pull just the relevant memories. Which brings us to the fourth pillar, orchestration.
Orchestration, flow control, retries, managing subagents.
Right. What happens when an API times out? Or a database throws an error? The model might just hallucinate a fake tool if it panics. Orchestration is the logic layer that anticipates those failures and reroutes the logic.
I picture it like a massive automated train switch yard. It reads the error, throws a switch, and puts the model on a diagnostic track.
Exactly. It's built on these directed acyclic graphs, or DAGs, so the model is corralled through a strict logic maze. But, and this is a big but, you have to have the fifth pillar, guardrails and security.
Right, because giving a creative text generator live access to your company's database is honestly terrifying.
It is. You need hard-coded sandboxing, strict permissions, and usually human approvals for destructive actions.
Which ties perfectly into Pillar 6, observability. You need to see if the task actually worked.
Yeah, logging and auto-evaluation, generating an execution trace so you can see exactly where the logic failed if the agent goes rogue.
And finally, Pillar 7, governance.
Oh, governance. This is the one that keeps CFOs up at night. Cost policies and compliance.
Yeah, the token costs. We definitely have to talk about the token costs later.
We really do.
So, okay, here's where it gets really interesting. Because the harness provides memory, tools, and this crazy orchestration, it unlocks multi-agent orchestration, moving from just one isolated task to complex multi-step workflows.
Yeah, this is where you see frameworks like LangGraph, CrewAI, AutoGen, Microsoft Agent Framework, OpenHands. They're all driving this.
Right, like those coding agents, Cursor and Aider, they don't just write code anymore.
No, not at all. They write it, they actively run the tests, they observe the errors, and then they fix their own errors in a continuous loop.
But what about when you have multiple specialized roles, like a harness orchestrating a planner agent, an executor agent, and a reviewer agent for, say, deep financial analysis?
That's the holy grail right now. You break the task down so you don't rely on one massive, expensive model for everything.
But I have a practical question here. If the harness is orchestrating these different AIs to talk to each other, like a planner and a reviewer, how do you prevent them from just getting stuck in an endless loop of arguing?
Oh, you mean like the reviewer flags a false positive, the executor rewrites it, the reviewer flags the rewrite?
And they just spin in circles, forever burning tokens.
Yes, exactly. And this is exactly why the orchestration and flow control component we talked about earlier, the budgets, the timeouts, the strict branching, that is the unsung hero of multi-agent systems.
Ah, so the harness steps in and breaks it up?
Completely. It imposes a rigid hierarchy. A developer might build a rule into the graph that says, if iteration count is greater than 3, route this to a human. Or it mathematically forces the executor to accept the constraint after round 2.
Wow. And the source also mentioned these self-improving loops, where the agent learns from its own execution, traces to actually improve its own scaffolding over time.
Yeah, looking at its own history to rewrite its tool use protocols for the next task.
So what does this all mean? I mean, we've got a self-improving team of agents. It sounds like literal magic, but we have to do a reality check here on the risks and limitations.
Definitely. Giving a text generator live tools is not for the faint of heart.
Exactly. I want to push back on the word autonomous here. If this system constantly runs the risk of exploding token budgets, and it still hallucinates on long tasks and requires this human in the loop just to stay safe, is it really autonomous? Or is it just a highly complex power tool?
That is such a valid point. If we connect this to the bigger picture, true autonomy is really a spectrum. The harness is just the bridge between a raw, unpredictable algorithm and something resembling a reliable digital coworker.
Because the hallucinations are still a massive issue, right?
Oh, absolutely. Agents still fail on long tasks. The compounding risks of errors over a long time horizon is severe. Strong verification and a human in the loop are mandatory right now.
And the costs. We said we'd talk about token drain. If it's running these continuous loops, the token usage must just skyrocket.
It does. It's quadratic scaling. Step 1 might be 1,000 tokens. Step 2 is that original 1,000 plus the new data. By step 50, you're sending massive payloads just to check a minor error. It gets expensive fast.
Because the governance pillar is literally saving companies from bankruptcy.
Literally. And then you have the security vulnerabilities. Giving AI tools opens up new attack vectors. And ethically, the harness amplifies the model's capabilities, but it also heavily amplifies its biases and its errors.
Right. If it's biased, it's going to act on that bias at scale extremely quickly.
Exactly. Building a good harness requires intense, solid engineering. The frameworks like LangGraph help, but they aren't magic wands.
And for scalability in the enterprise, the text points out the need for standardized protocols, things like MCP and A2A.
Yeah, MCP Model Context Protocol. It's basically the universal plug for agent data and A2A, agent-to-agent communication. It's a tedious plumbing, but you absolutely need it if you want an HR agent to safely talk to a supply chain agent.
So bringing this all back to you listening today, the era of prompt engineering being this ultimate AI skill,
Hmm.
it's kind of fading, isn't it?
It really is. I mean, prompting is still useful, but leading in the tech space in 2026 means mastering harness engineering.
Exactly. The competitive advantage is in building robust state machines and tight governance loops. And Source actually gave some great advice on this.
Start small.
Start small. Try out LangGraph or CrewAI on a personal project. Once you map out a simple logic graph yourself, you'll immediately see the power and the terrifying ways it can fail if your edges are poorly defined.
It's a humbling experience for sure.
Definitely. But before we wrap up, I want to leave you with one final thought to mull over, building on all this. If 98% of a highly effective AI agent is actually the deterministic software harness wrapped around it.
Then maybe the current limitations of artificial intelligence aren't actually limits of the AI's brain at all.
Exactly. It's the limitations of human software engineering. We're still figuring out how to build the body to support this brain.
That is a fascinating way to look at it. And if I can add to that, think about how these agents interact, using MCPs and A2A protocols to directly query databases.
Oh, right. They don't need a graphical user interface.
Exactly. Agents don't click buttons on a screen, which means the entire concept of the human UI, the apps and dashboards we've spent decades perfecting, that could all become obsolete legacy architecture.
Wow. We might just stop building software for human eyes entirely. The screen itself could just be a temporary stepping stone in computing history.
It's a structural shift we all need to anticipate.
Well, that's definitely something to keep in mind as you look at the tools you're building today. Thanks for taking this deep dive with us. Get out there, start mapping your logic graphs, and we'll catch you on the next one.